The last question is on convolution. This problem has us convolve our x of n or their h of n. There's two ways to do that. We can do it mathematically or graphically. To do it mathematically, we evaluate this summation over all k of x of k h of n minus k. And we have to do this entire summation for every value of n in y. So for n equals 0, we do the summation. For n equals 1, we do the summation, and so on. You can do it mathematically, or we can do it graphically. Let's do. The question asks us to do graphically. So to do it graphically, we can see that as n changes, x of k does not. So we're going to regraph this x of n as x of k. And we get 0, 0, and these two values are 2 at n equals 2 and 3, and everything else is 0. So this is our x of k that we've just drawn. So that's our first part of our equation. And now we're going to draw our second part of our equation. So that's going to be, we have to choose a value of n. So we're going to start off finding what is y of 0. In other words, we're setting n equals 0 to this, and we are going to graph h of minus k. So this is our flip and shift method. And our h of minus k is just this flipped around. So now we've got still have 0 here. We're always flipping it around the vertical axis. But now at 1, 2, and 3, we have values of positive 1. And everything else is still going to be 0. Okay. So now we can multiply our x of k with our h of 0 minus k. And we'll have our first product that we can sum to find our y of 0. So when we multiply these, we see we're always multiplying zeros by zeros out here. 0 by 0. Finally, we get to a non-zero. We have a couple of spikes at 2, and then all the rest will be zeros. So when we sum this up, when we finally pull all that into our summer over here, we get sum of 2 plus 2 is 4. So therefore, y of 0 is equal to 4. So that's our flip. And now we're going to shift. Now we're going to do the same thing, but we're going to find y of 1, which will just take this and shift it to the right by 1. In other words, what we're going to graph is we're going to graph h of 1 minus k. This shifted to the right. Shifted to the right, we now have our 3 values are now occurring at 2, 3, and 4. So now when we multiply our x of k with a shifted h of 1 minus k, we get zeros on the left, since this is 0. At 0, we have 0 times 0, so that's 0. At 1, we have 0 times, doesn't matter, it's going to be 0. At 2, we have 2 times 1, which is 2. At 3, we have 2 times 1, which is also 2. At 4, we have, well, this is going to be all 0, so it doesn't matter what our h of 1 minus k is. The product is going to have to be 0. So this shows us that y of 1 is going to be the sum of these two guys, and is 4. So we can shift it to the right one more time. Now, you can see here that this is the part, this here are the only non-zero parts. So we're shifting it to the right. So when we shifted it to the right by 1, we still had this overlap by 2. But if we shift it to the right by 2 to find y of 2, shift it to the right by 2, boom, boom. And now the only place that it's going to overlap our original x of k is going to be in this one location. Everything else will have zeros. So when we multiply it now, we'll just have a single spike here, and that means that the sum will only be 2. And if we shift it to the right still further, now if we shift it 3 to the right, 1, 1, 2, 3, now there's going to be no overlap between h of 3 minus k and x of k, and so that'll have to be all zeros out there. Similarly, I think it's clear that if you shift this to the left by 1 to find y of minus 1, and you shift it to the left by 1, the only part that will overlap will be this value at index 2 with this one that's now shifted to the left, so it'll be at index 2. And that'll give us just a single peak at 2, which will sum to 2. And any values of y for shifts more than of 2 or more to the left, this h of n of 2 minus k, or h of 3 minus k, or h of 4 minus k, when it's been shifted that far back, it won't align with x of k at all, and it will get all zeros. So from that, we can say that our y of n is going to be, we found it's equal to 4 at y equals 0. At y equals 1, it was also 4. At y equals 2, it dipped down to 2. And for any values greater than that, we found it was 0, because there's just no overlap. Similarly, for y equals negative 1, we found it was 2. And for any values of n less than negative 1, our output is 0. So that's our answer. Although it wasn't asked in the problem, let's do it mathematically. So y of n equals that sum over all values of k of x of k h of n minus k. So let's calculate it let's find out what y of 0 is. That's going to be the sum from k equals minus infinity to infinity of x of k, h of minus k, so we're putting in 0 for n. I can't do the summation for all infinity, but I think it's pretty clear from here that the only places that we've got values are in that range of -3 to +3. If we go beyond that, we'll always be multiplying by zeros guaranteed. So let's do that for the sum from k equals -3 to +3 of our x of n, h of minus k. So that's just a fancy way of saying that we're going to substitute k, whoops, that should have been x of k. That's just a fancy way of saying we're going to substitute in k equals -3 first. So substituting k equals -3 and taking the negative, that gives us +3. So this is what we get when we substitute in k equals -3. And then to that, we're going to substitute in a k equals -2. We're going to add it, x of -2, h of 2. Do the same thing for -1, x of -1, h of -1, which is +1, x of 0, h of 0, plus x of 1, h of -1, and we'll continue all the way on up. Now, I need to continue all the way up, plus x of 2, h of -2, and x of 3, h of -3. And just to confirm our intuition, so this last one was for k equals +3. And just to confirm our intuition, as we move still further up, now our inputs x are going to be 0, so we really don't need to go any further up than 3. So let's start substituting in values here. For this first one, x of negative 3, well, that's going to be 0. So it doesn't matter what it's multiplied by, that part will be 0. The second one, so this was our k equals negative 3. Our second one at k equals negative 2, x of negative 2 is also 0. So it doesn't matter what h of 2 is, our answer is going to be 0 for that k equals negative 2. Our next is going to be at k equals negative 1. Same thing, h of negative 1 is 0. Our next is the one we figured out at k equals 0. That's going to be 0 times 0, so that's also going to be 0. Our next at k equals positive 1, we have x of 1, which is 0, so it doesn't matter what h of negative 1 is. Okay, next one, x of 2, we're going to do k equals 2 here. So x of 2 is positive 2. And our h of negative 2, 1, 2, is negative 1. I'm sorry, is positive 1. Our h of negative 1 is positive 1. So just to make it perfectly clear where we got those numbers, this number is this, and this number is this. Continuing on for k equals 3, we have x of 3, which is 1, 2, 3. It's positive 2. And we have h of negative 3, which is positive 1. So this whole thing collapses to just 2 plus 2, which is 4. And you could continue to do this work on and find next what our value is for y of 1. And that would be the summation over x of k times now h of 1 minus k. And just like y of 0 is found to be 4 using math, y of 0 is found to be 1. Y of 0 is found to be 4 using this equivalent graphical method where we just flipped our h over and multiplied them together. And this 2 times 1 and 2 times 1 for indices 2 and 3 correspond to this 2 times 1 and 2 times 1 for indices k equals 2 and 3. If you did it by math entirely, you'd have to do this sum next, you'd have to do this sum next, and continuing on, you'd have to do them for all the values that we did it graphically so much more quickly.